On April 2019, we made history. We saw the first interstellar visitor in our solar system. And since then, we've had 2 more interstellar visitors. That's right. We're talking about comets that have an origin outside of our solar system. And one of them is making its way to Perihelion, which means it will be passing close to the Sun this year. And this is what you need to know. We're going to talk about how scientists found this comet, where it came from, when it's going to pass the Sun, and what we can learn from it. First off, let's talk about what makes a comet interstellar. It all has to do with their orbits. Comets are known for having really long orbits around the Sun. But if they have orbits that extend as far as other solar systems, well, that means they didn't originate in our solar system. So interstellar comets have orbits that take them outside of our solar system. And while there have been many comets that could possibly be interstellar in origin, the first comet officially labeled as such was 1I Oumuamua. This was back in 2017 when it passed through our solar system, and astronomers knew, based on its orbit, that it was an interstellar traveler. Then there were some questions about whether or not it was a big spaceship left by an alien civilization. Yeah, no kidding. But after scientists ran tests and did a bunch of analysis, they determined that it was just a regular old space rock. Since then, we've had 2 other confirmed interstellar guests, both of which are long-period comets. Long period means that their orbits around the Sun take more than 200 years. And the first one we saw was Comet Borisov, also known as 2I. Just like with Oumuamua, it was the first of its kind. When it entered our solar system, astronomers could look back and see that its path did indeed take it outside of our solar system. Comet Borisov is about half a mile wide, and according to NASA, it was the cleanest object ever seen in deep space. Meaning it gave astronomers a good look at what it was actually made out of. And this is important because while we were still trying to find out exactly where these interstellar objects come from, we can analyze the makeup of these rocks and maybe get some clues. For example, one theory is that these interstellar objects come from the Kuiper belt of another star system. The Kuiper belt is the region beyond Neptune. And so if we find that the composition of this comet is similar to some of the Kuiper belt objects that we know originated in our Kuiper belt, that would be evidence supporting this hypothesis. And now we have 3 IATLAs, which was discovered in 2019. And because of its shape, scientists estimate that it's about 1 kilometer across. And based on its path, they knew that it had an interstellar origin. Scientists were able to use data from the Solar Terrestrial Relations Observatory, aka STEREO, to help confirm this. STEREO actually consists of 2 spacecraft launched in 2006 that went ahead and went their separate ways. They orbit the Sun, but from different viewpoints, which means they can capture images of things that are either approaching or receding from the Sun. And in 2019, they captured a view of 3I Atlas that showed it had a tail over 25,000 miles long. And this was when it was still more than 3.5 billion miles away from Earth. Talk about a long tail. Now, while astronomers have been able to confirm that these 3 comets are interstellar, they haven't yet figured out where they come from. We mentioned earlier that one hypothesis is that they come from another star system's Kuiper belt. But there are a few other hypotheses. There's one that says these objects come from the outer reaches of the Oort cloud. The Oort cloud is a theoretical sphere of icy rocks that surrounds our solar system. While we don't have direct evidence that it exists, we do see things in deep space that seem to indicate that it should exist. And then there's the hypothesis that says these interstellar objects are actually rogue planets that got kicked out of their planetary system. So why can't scientists figure out where these interstellar objects come from? Well, it's because they're only here for a brief time. When they enter our solar system, they're already on their way back out. Like, think of it like you're at a party and someone comes up to you and says, "Hey, where did you come from?" You can tell them the city that you're from, but you can't tell them where you were specifically before that. That's kind of how these interstellar objects are. They enter our solar system, and then they're gone again. And all we have is the path that they leave behind, which can tell us some things, but it doesn't tell us everything. In the case of 3I-ATLAs, though, we have a bit of a silver lining. That's because, unlike the previous two interstellar objects, 3I Atlas is going to pass the Sun this year. That's right, it's en route to Perihelion, which is the point in its orbit that brings it closest to the Sun. And this will happen on February 2024. And it's expected to reach a distance of about 110 astronomical units from the Sun. 1 astronomical unit is equal to the average distance between the Earth and the Sun, which is about 150 million kilometers. Because 3I Atlas is going to pass so close to the Sun, astronomers expect that it might start to break apart due to the Sun's gravity. But even if it doesn't, astronomers will still get valuable information from this flyby. For example, thanks to the European Space Agency's Gaia mission, scientists have been able to measure the exact orbit of this comet, and that means they'll be able to determine its mass. With the upcoming flyby, they can compare the observed brightness of the comet with its known mass to estimate its size. What is interesting is that it's expected to be about twice as bright as Comet Borisov was at its peak. And Comet Borisov was quite the spectacle. NASA reports that at its brightest, it was shining at about 10 times the standard brightness of a 10th magnitude star. While you woe and be able to see this comet with the naked eye, unless you live in the southern hemisphere and your skies are really dark, it's still a sight to behold. And according to NASA, you'll need a telescope or a backyard telescope or a digital camera to capture this comet at its best. But aside from getting to see a once-in-a-lifetime event, what else is so great about this upcoming flyby? Well, for one, astronomers will be able to study the dust that it leaves in its wake. With the previous two interstellar objects, they were unable to leave much behind, because they were pretty much already at aphelion when we saw them. Aphelion is the point in an orbit that is farthest from the Sun. And so, with those two comets, they were leaving our solar system when we found them. But 3I-ATLAS is doing the opposite. It-S entering our solar system, and it-S expected to leave behind dust that may help scientists understand how planets form. That is because the dust left behind by these comets is the same stuff that stars and planets are made of. And we believe that something similar to comets brought water and other organic molecules to Earth. So studying the makeup of this dust can help us better understand the conditions that led to life on Earth. Not only that, but we can also use the dust to study the chemistry of these interstellar objects. And finally, 3I-ATLAs will pass close enough to Earth for astronomers to get a good look at its surface. They'll be able to study its color, look for any surface features, and perhaps even take its temperature. This is also a chance for Earth-based telescopes to show what they can do. It's likely that most of the observations of this comet will be done from the ground, which will hopefully yield some groundbreaking results. So mark your calendars for February 2024. We have a long way to wait, but it'll be worth it. And who knows, maybe this comet will have a surprise or two up its sleeve. After all, 1I Oumuamua surprised us when it broke apart in ways that astronomers didn't expect. And while we don't know what to expect from 3I-ATLAS, we do know that this comet has a very special guest coming along with it. This is a special video because on the day that it releases, the comet itself will be making its way to perihelion. That's right. The two of us and this comet, we're going to be reaching our perihelions on the same day. And if you want to celebrate this momentous occasion, you can head on over to our website and get yourself a heliocentric calendar. These calendars are modeled after the solar system and are designed so that each planet is in the position that it's actually in relative to the Sun. This means that the farther out a planet is, the slower it moves. So you can keep track of the inner planets as they zip around the Sun, but you'll have to slow down your tracking device for the outer planets. Not only does this make for a cool conversation piece, but it's also a good learning tool. This is especially true of our new Marvel edition. It's modeled after the solar system, but instead of the planets, we have Marvel characters. Each character is in the position that their corresponding planet is in, which means that Thor, who is farthest out, will move the slowest. And Loki, who is closest to the sun, will move the fastest. And hey, if you order today, you can get free shipping. So check it out.